Welcome to the session Project Management and PERT CPM. PERT Project or Program Evaluation Review Technique and CPM Critical Path Method are the two methods of project management. Before any activity begins related to the work of a project, every project requires an advanced, accurate time estimate. Without an accurate estimate, no project can be completed within the budget and the target completion date. PERT and CPM help us to complete a project within the stipulated time and budget. So, let us understand first what is project. A project is a series of activities to accomplish a specific objective. Project management involves project planning, monitoring and controlling. Successful project management ensures the completion of project in time within the budget and specification. Let us familiarize project with a simple example. Arranging for a tea party. It is a project. The project arranging a tea party requires the following activities: invite guests, procure materials, prepare snacks, arrange for the dishes, prepare tea, arrange seats, set table with snacks and dishes and clean the table. From the above example, it is understood that each activity needs physical time for its completion. Certain activities are interrelated. For example, tea cannot be served until its preparation is completed. Each activity will require one or more of the resources such as manpower, raw materials and equipments. The project will be completed only if all of its activities are completed. Network representation of projects. Network analysis is a must for studying PERT and CPM. Network analysis is a technique related to the sequencing problems which are concerned with minimizing the performance of the system, such as the total completion of the project, overall cost, etc. In other words, network analysis is a system which plans project by analyzing the project activities. It is one of the most popular techniques used for planning, scheduling, monitoring and coordinating large and complex projects comprising a number of activities. Objectives of network analysis. It is a powerful tool for planning, scheduling and control of project. It shows a simple way of the interrelationship of the various activities of constituting a project. Minimize total cost, minimize total time. It leads optimal use of resources. It avoids production delays, interruption and conflicts. It provides a comprehensive idea about the project and it provides up-to-date information through frequent reporting. Terms related to network analysis. Network is a series of related activities which results in some product or service. Network diagram. It is a diagram which represents the activities and events of a network, their sequence and relationship. Activity of network represents project operation or task to be conducted. It is an element of job or task or item of work to be completed in a specific time period. Activities require the expenditure time and resources for their accomplishment. Each activity is represented by an arrow. The head of the arrow indicates the sequence or flow of activities. An activity cannot begin until the completion of the preceding activities. The activities can be classified into three categories. They are: 1. Immediate predecessor activity, 2. Immediate successor activity and 3. Dummy activity. If an activity B is supposed to start immediately after activity A, then A is called the immediate predecessor of B and B is called the immediate successor of A. Diagrammatically, it can be shown as below. If a project contains two or more activities which have some of their immediate predecessors is common, then there will be a dummy activity. Dummy activity is an imaginary activity which does not consume any resource. It indicates the predecessor or successor relationship clearly in any activity. Critical path method CPM. CPM was developed in 1956 by Morgan R. Walker of DuPont Company and James E. Kelly of Remington Rand, both in USA. CPM is an activity-oriented method of project management. Here, emphasis is given to activities of the project. It is a network technique involving the preparation of network in the form of diagram. It is analyzed to locate critical path. After preparing the network diagram, we can locate the various possible paths. From that, we can determine critical path. CPM emphasizes the relationship between resources to shorten the duration of given jobs and increase the cost of these additional resources. CPM operates on the assumption that there is a precise known time that each activity in the project will be taken. Critical path analysis. The main objective of critical path analysis is to estimate the total project duration and to assign starting and finishing times to all activities involved in the project. The following terms are related with CPM. Path. It refers to unbroken or continuous chain of activities from start event to end event in the network diagram. Critical path. Critical path is that sequence of activities which determines the total project time. Critical path is the continuous chain of critical activities in a network diagram. It is the longest path starting from first to last event and is shown by the thick line or double lines in the network diagram. Activities lying on the critical path are called critical activities. An activity is said to be critical if a delay in its start will cause a further delay in the completion of entire project. Length of critical path. It is a sum of individual times of all critical activities lying on it and defines the minimum time required to complete the project. To determine the duration of individual activities in CPM, 4 activity times are to be computed. First one, earliest start time. EST. It is the earliest time at which an activity can start. Second one, earliest finish time. EFT. It is the earliest starting time plus activity time, that is EST, that is earliest starting time plus activity duration. In other words, it is the earliest time by which an activity can be finished. Latest start time, LST. It is the latest time by an activity can be started without delaying the completion of the project. It can be found by deducting activity duration from latest finish time. LST is equal to LFT minus activity duration. Latest finish time. It is the latest time by which an activity can be finished without delaying the completion of the project. Steps to determine the critical path. Break down the project into various activities systematically. All the activities are to be arranged logically. Then construct an arrow diagram. Number all the nodes or events and activities. Mark activity time on arrow. Calculate earliest start time, earliest finish time, latest start time and latest finish time and mark these times on arrow diagram. Determine total float for each activity. Total float of an activity is defined as difference between the latest finish and the earliest finish of the activity or the difference between the latest start and the earliest start of the activity. The activities with total float 0 are the critical activities. Locate the critical activities. The activities with 0 float are the critical activities. Connect these critical activities by double line arrow. It is the critical path. Then calculate the total project duration. Next, advantages of critical path method. It helps the top management to concentrate their attention to the critical activities and their completion in time. It helps to locate the critical and non-critical activities. The management can transfer resources of non-critical activities into critical activities for the completion of the project in time. It helps to plan and schedule a project. It provides relevant information about the duration, size and performance of an activity. Here is a simple example. Start, task A, then task B, task E, end. Then again from start, task D, task C, task F, then end. In this project, there are 5 parts. The part 1 is A, B, E. Start, task A, task B, task E, end. Then again start, task D, task C, task F, end. The second path is ACE. Start, task A, task B, task E, end. Then again from start, task D, task E, task F, end. The third path is ACF. Start, task A, task B, task E, end. Then again start, task D, task C, task F, end. The fourth path is DCE. Start, task A, task B, task E, end. Start, task B, task C, task F, end. Start, task A, task B, task E, end. Then again start, task D, task C, task F, end. And the fifth path is DCF. Start, task A, task B, task E, end. Start, task D, task C, task F, end. The length of each path is shown below. Start, task A 15 minutes, task B 20 minutes, task E 10 minutes, end. Then start, task D 30 minutes, task C 15 minutes, task F 5 minutes, end. A plus B plus E 45, A plus C plus E 40, A plus C plus F 35, D plus C plus E 55, D plus C plus F 50. So, it is understood that DCE is the critical path. Program or Project Evaluation and Review Technique, PERT. PERT or Project Evaluation and Review Technique is a project management tool developed by the government contracting company Booz Allen Hamilton in Virginia in coordination with the US Navy in 1957 to support the US Navy's Polaris nuclear submarine project. It was also used in the Fleet ballistic missile program in 1958. It is more of an event-oriented technique rather than start and completion oriented and is used more in projects where time is the major factor rather than cost. It is applied to very large scale, one-time, complex, non-routine infrastructure and research and development projects. Now, this technique is popular in business and other organizations. PERT assists business managers in planning and controlling a project. So, it is a management technique. It allows a manager to calculate the expected total amount of time required to complete the entire project. At the same time, it helps to highlight critical activities of the project. Identification of critical activities helps the manager either to allocate more resources or keep a careful PERT is preferred for those projects which are of non-repetitive nature or for those projects in which precise time determination for various activities cannot be made. In PERT, it is assumed that the time to perform each activity is uncertain. PERT incorporates the statistical analysis in determining time estimates. PERT planning involves the following steps that are described below. Identify the specific activities and milestones. The activities are the tasks required to complete a project. The milestones are the events marking the beginning and the end of one or more activities. It is helpful to list the task in a table that in later steps can be expanded to include information on sequence and duration. Determine the proper sequence of the activities. This step may be combined with the activity identification step, since the activity sequence is evident for some tasks. Other tasks may require more analysis to determine the exact order in which they must be performed. Construct a network diagram. Using the activity sequence information, a network diagram can be drawn showing the sequence of the serial and parallel activities. Each activity represents a node in the network and the arrows represent the relation between activities. Software packages simplify this step by automatically converting tabular activity information into a network diagram. Estimate the time required for each activity. Weeks are a commonly used unit of time for activity completion, but any consistent unit of time can be used. A distinguishing feature of the PERT is its ability to deal with uncertainty in activity completion time. For each activity, the model usually includes 3 time estimates. They are optimistic time estimate, most likely time estimate, and pessimistic time estimate. Let us have a brief description of each of these time estimates. First one, optimistic time estimate. It is the shortest possible time in which an activity can be completed under ideal conditions if everything goes well. There is a very little chance that activity can be done in time less than the optimistic time. It is the estimate of minimum possible time which an activity will take to complete within ideal situations. Most likely time estimate. It refers to the estimate of the normal time that the activity would take. It is the model value. Pessimistic time estimate. It is the maximum time that an activity would take if everything goes wrong and abnormal situations are prevailed. Most likely time estimate lies in between optimistic time estimate and pessimistic time estimate. The difference in these 3 times gives a measure of the relative uncertainty involved in the activity. From the above 3 time estimates, the expected time of each activity would be calculated by using the following formula: T raised to E equal to T raised to 0 plus 4 T raised to M plus T raised to P all divided by 6. Determine the critical path. The critical path is determined by adding the times for the activities in each sequence and determining the longest path in the project. The critical path determines the total calendar time required for the project. Difference between PERT and CPM. First one, CPM is activity oriented, that is, CPM network is built on the basis of activities, whereas PERT is event oriented. Second one, CPM is a deterministic model. It does not take into account in uncertainties involved in the estimation of time, whereas PERT is a probabilistic model. Third one, CPM places dual emphasis on project time and project cost, whereas PERT is primarily concerned with time only. Fourth one, CPM is primarily used for projects which are repetitive in nature and comparatively small in size, whereas PERT is used for large one-time research and development type of projects. Now let us summarize the session. Both PERT and CPM are pure management techniques. As we discussed above, they are 2 important project management techniques. Presently, these techniques are used not only in business organization but also in service organization. Since libraries are service organizations, these techniques are used for library management. In the case of libraries, shifting of libraries, library automation, constructing of digital libraries, stock verifications are treated as projects, and these are done with the help of PERT and CPM. Here are some questions for you to work out. First one, What do you understand by PERT and CPM? How is it useful to decision makers? Second one, how is PERT useful in accomplishing project objectives? Here are some books for your references. First one, Kumar PhD 2003, Management of Library and Information Centers, New Delhi, BR Publishing Corporation. Second one, Rajagopalan SP 2009, Business Statistics and Operations Research, New Delhi, Tata McGraw-Hill. Third one, Venugopal 2013, Operations Research, Calicut University Press. Thank you for watching this session. We will discuss another topic in the next session. Till then, bye.